Hello, in this lecture we are going to cover the Linux boot process, and especially the process that has been utilized in the newer version of Linux operating systems. The boot sequence changes in CentOS and Red Hat 7 and above, and some of the other operating systems as well. So if you're using Red Hat 5 or CentOS 5 or 6, you're probably going to notice that it has or it uses a different boot process. In the newer version of CentOS or Red Hat, it actually utilized a different boot process, and this is what we are going to cover. The systemd is the new service manager in CentOS and RHEL 7 that actually manages the boot sequence. It is backward compatible with System 4 in its System 5 in its scripts used by previous versions of Red Hat in Linux, including RHEL 5 as well. So you could use this boot process to run that could run on the previous versions as well. Now, every system administrator needs to understand the boot process of an operating system. I would say whether it's Linux, Windows, or whatever the operating system is, in order to troubleshoot more effectively. Because what happens if the system doesn't boot? Then you need to understand all the sequence where it goes through, how it goes through, which file it reads, so you could troubleshoot and go through each of them to identify the problem. So let's go into the next slide and I will show you in a graphical way how this boot process works. The first thing first is as soon as you power on a machine or a computer, it actually has a firmware in it. And remember that firmware, it has nothing to do with the operating system. That firmware actually comes in with that machine pre-installed by that manufacturer. That firmware is called BIOS, which is referred to as basic input and output setting. So it starts up, it takes the power on, it starts up, and it goes through the post process. And the post process is power on, self test started, meaning it starts up and then it goes through all the hardware that is attached that makes the entire computer system. It goes through every one of them and checks, hey, you okay? Are you okay? Are you up? Are you up? Are there any problems with the hardware? So it goes through that post check. After that, the MBR is loaded. MBR stands for Master Boot Record. The information is saved in the first sector of the hard disk. That is referred to as MDR, which indicates where the grub2 is located, so it can be loaded in the computer RAM. So BIOS looks up, does the post, and then it goes to the first sector of the disk and finds out that MBR. MBR has the information of grub2, and the grub2 stands for Grand Unified Boot Loader, and it is called as 2, meaning version 2, and it predates version 1, which doesn't have 1 on it, but it just says grub. So basically, grub 2 job is to load the kernel, the Linux kernel, and that information is in slash boot slash grub2 slash grub.cfg, which is the config file. So when you boot up your Linux operating system, you probably don't see the BIOS and post because it goes through your screen so fast. And MBR is probably not noticed because that's the time your machine is looking for that sector. But you will see at one point on your screen, on your black screen, it's going to show up as Linux kernel. And sometimes you're probably going to see 1, 2, 3, or 5 different kernels that it needs to boot from. So you could at that time also move your cursor up and down and select the kernel you want to load, or let the system decide which kernel it's going to load depending on that grub configuration. Alright, so now the kernel comes up. Kernel says, okay, the grub asks me to start. Okay, the kernel is the core of the operating system. So what it does is it loads the required drivers from initrd.img file. Now this is the kernel's job, is to load the driver, meaning every hardware that is attached to your machine, in order for it to work, the kernel has to communicate to that hardware. So the kernel, in order for kernel to communicate, it has that driver that talks to the hardware. So it loads up all those hardware, and then it starts the very first OS or operating system process, that is called systemd. Now systemd, as I said earlier, it's a new process introduced in the newer version of Linux. So it starts up. The next step is the last step. The systemd starts up, and of course this is the first process in the system, and by default it is given a process ID of number 1. As the other process starts, they gets the incremental numbers of the process. It's then start all the required processes that is needed, that were enabled at the boot time. Then it reads the etc system default.target file. This to bring the system to the run level. Now every Linux system has a total of 7 run levels that goes from 0 through 6, which defines where it's going to start. It needs a networking single user mode, or if it actually needs to shut down. All those run levels are actually defined in default.target file. So it looks up that in that file, sees which target file it has to, which run level it has to start, and that's how your system becomes online. So this is the Linux boot process, and as I said, this is a newer process that's introduced lately in newer versions. So definitely go through this. This is one of the important things that every system administrator needs to know, needs to remember while they are troubleshooting the issue. All right, good luck.